Hi, welcome back, guys. I just want to give you a little bit of help more on the SOHCAHTOA stuff in case you needed it. I ended with saying that, hey, sine of some angle is defined as the opposite side of that from that angle over the hypotenuse. To draw a right triangle, I have to pick one of these two angles to look from, and if I was looking from this side, okay, the opposite side, or this angle, the opposite side would be over here across from, okay, and then the hypotenuse would be here. Okay. So this is just a way that they came with this ratios. Okay, they came up with ratios. Hey, they're going to say the sine of this angle is we're going to take the hypotenuse length divided by the opposite length. And it's going to be the same no matter how big that triangle is. Okay, if this angle stays the same, it's still going to equal the same number once we take the opposite over the hypotenuse. Okay, because these things, they're similar triangles, the sides stay in proportion. So there's a big old long chart about all these sine of all these angles, starting from, sine of 1, sine of 2, sine of 3, sine of 4, and it all gives all these lists of numbers. Okay, the calculator is what you'll be using to figure out the unknowns once you get into the MyLab and mastering. Okay, for instance, if you had an unknown of, let's say this was a 30-degree angle, instead of just calling it some random angle, let's say it's 30 degrees. So in your calculator, you type in 30 degrees, and then you click the sine button. Okay. And it would give you 0.05. That would be the ratio of those two sides. Now, notice this is not two numbers, this is one number. Okay, it's already taken the opposite and divided it by the hypotenuse in your calculator, and it comes up with 0.5. This is the same thing as 1/2, which you might recognize from the 30, 60, 90 degree triangles. Okay, the opposite side from here would be a 2. Okay, or sorry, would be a 1. I didn't draw this very accurately. Would be a 1, and this would be a 2. So really, I should have drawn it to scale more, so that you'd maybe recognize it easier. Okay. Really, this is how it's more would look like, and this would be a 1, and this would be a 2, and then this one we didn't even deal with, but the adjacent side would be square root of 3. Alright, you can do that for any of the trigonomic ratios, including cosine, which I defined as adjacent over hypotenuse. Okay. So if we had a triangle that looked like this, and let's say this is 45 degrees, and I wanted to take the cosine of that angle, right, it would be the adjacent side over the hypotenuse side. And if you type that in your calculator, 45, and take the cosine of it, right, you should end up with, let me think for a minute here, this is going to be square root of 2 over 1. You should end up with square root of 2. No, should end up with 1 over the square root of 2, which would give you a decimal approximation of 0.707. Okay, so it's kind of a weird number. And then if you needed to solve for one of these unknowns, let's say they said this was 1. All right, or let's do a little bit harder one. All right, let's say they said this side was 2, this is a 45-degree angle, I want you to find the hypotenuse length. Okay, that's a question you might come up with. Well, first you can just type cosine of 45 in your calculator and get 0.707. All right, and then it's going to equal, because we figured out this was 0.707 from our calculator, it's going to equal the adjacent side, which is 2 in our case, over the unknown, which is x. Now to solve for that, okay, to solve for x, we got to get x out of the denominator, so I'm going to multiply that by x both sides, and I get 0.707 times x equals 2. Well, now to get x by itself, now that's in the numerator, I can just divide both these, and I get 2 divided by 0.707, and I get x equals 2.83 approximately.